Hey guys, and welcome to today's update video. Let's take a look at the current status of our bot, of our Super Mario AI. I'm going to start a new game. Now the first thing you're going to notice is that I've got this nice bounding box around Mario that follows him around really well. So I've done some code refactoring, and I'll talk about the code after I go through the introduction section. But essentially, it's a lot easier now for us to create templates. So I really spent some time refining that process. So Mario's got this nice bounding box around him, which looks pretty good. You can see that the Goomba has a red bounding box, so I'm going to use red colors for things that are like hazards. Now one quirk that you're going to notice is if I look to the left, the bounding box disappears. That's simply a function of the fact that I'm controlling Mario, and the game is going to expect Mario to be facing right unless it presses to the left. Now I can kind of override that by manually telling the game to do that, so you can see how that works. So that's just a small little bug in the current implementation, not a big deal. Let me just fix that so it's not confusing. So another interesting thing you're going to notice is that now blocks are identified by the game, but it's a little bit quirky, and it's due to the fact of the way that we're doing our match templating. So right now, our match template functions are essentially finding the best match. And you can notice that only one of those three sets of bricks is being highlighted in purple. It's kind of alternating. And the reason for that is, there's small variations in the screen when those things flash and whatnot. So it causes the calculations maybe to round one way or round another way. But essentially, it's looking across the whole screen for bricks, and it's just finding the best one. And that's not what we want. We need to identify all the bricks. So the next big update to our program in the next videos, I'm going to work on showing how to use match templating to combine results and get all of the objects and not just the single one. But right now, for objects that only have one thing on the screen, the match template's working quite well. So here I can make the mushroom pop out. You can see that that's going to be a green item, and it's blinking green. Now another thing you might be wondering is, oh, and by the way, the pipe is kind of buggy. That's just a placeholder. I'm still trying to figure out how to implement the pipe the way I want to. But let's talk about, why does Mario have a solid blue box and other objects seem to be blinking, like the purple around the bricks and the pipe? And the reason for that is I've refactored the code a little bit so that our match templating is able to assign templates with what I'm calling a priority. So certain things are going to have the highest level of priority. That's going to be things like enemies, and it'll be things like Mario. Because when you're playing the game, you want to make sure that you have a good match for where Mario is on the screen and where the enemies are on the screen. That's probably the most important thing. It's less important to know exactly where the blocks are normally. And also the blocks don't move around or anything. So we can get away with only intermittently sampling that. So this is a way to speed it up. Same thing with this mushroom. The mushroom's not a hazard, it's a good thing to get. It's important. So we might want to assign a slightly lower priority so that only gets updated every X number of frames. That way this thing can continue to run quickly and focus on the most important parts. Now you'll notice that the Goomba has the red outline, and his red outline is solid red, and that's because enemy I have currently set as a priority 1, like Mario, and again, red is going to be a hazard. So we can play with that. We can determine what's going to make the most sense as we actually start experimenting with this thing. But that's kind of that's a utility that I wanted to build in, because it's going to start to get expensive the more things that we try to calculate for. If we try to find lots of objects at the same time, we're going to need some way to prioritize what gets calculated and rendered, and what gets pushed to another cycle. Now with the Goombas, again, you're going to notice the same phenomenon. We've got multiple Goombas on the screen. When multiple ones are on the screen, it's bouncing around because it's at any instant in time, it's trying to find the best one at that time. Again, we will fix that once we implement the capability for it to detect multiple objects. And here, similar thing here. I haven't implemented the flower yet. We can get to that later. And then there's the turtle. Same thing. The turtle's got the red box. That's a solid red box because there's only one turtle on the screen. So that was pretty easy for the game to identify. So that's the current status of the bot. Our collision detection and our localization of objects is getting a lot better. It doesn't look like a big jump over the last one, but once we talk about the code refactoring, I think you'll understand just how much better the code is right now. I also want to show you guys the GitHub repository that I've created for this project. So if you go to my GitHub repository, which I will link in the description below, guys, you'll be able to pull this code. All the code is right here. It's in this folder, and you can pull all this code. You'll be able to run this with run.py. That will give you the capability to run this just like I did. So let's look at the code, guys. Okay, so here we are in the code. Let's just quickly look at all the files that we have. We have run.py. This is going to create our Mario AI instance, and you're going to set the screen corners like I did here. You can set that to whatever your requirement is, like we talked about. And then we start the screen capture process, which is essentially starting the whole thing. Let's look at some of the changes that I made. So first, let's take a look at templates.py. So this is the biggest change, I would say, from the last time we looked at this project, one of the biggest changes. Okay, so let's look at the assets that we have. First of all, I created a bunch of templates. So I've got my Mario for big and small, I've got my mushroom, I've got some pipe ones that I'm playing with, my blocks here, my Goomba, and my turtle, okay? Like we talked about before, because the template, we want it to be square, rectangular, you're gonna have to chop out a rectangular piece that ideally does not include a background element. Now, if we run into something where that's totally not possible, we'll take a look at it. But essentially, this is what I came up with for my bricks. Some of these bricks flash, for example, so we grabbed a couple different versions of it. We've got our enemies here. We've got Mario. Okay, this is the folder that I'm going to dump all of my templates in, and I'm going to give them a name. So let's look at templates.py. Templates.py is what allows our AI to load all these templates in right when we start it up. Once we boot it up, it loads them all in, it sets up all the information so it knows exactly how to use all of these templates. And the way I've done it is I've named each of these with the same name as the file, essentially. So for example, Mario Small is this file right here, and the file is in the assets templates mariosmall.png. That tells the AI where to load the image in. I've also provided it with some more information. So depending on where you set the top left-hand corner, you might want the bounding box to be bigger, wider, offset a little bit because you want to try to get the whole object if you're only using a chunk out of the middle. So I've also created a height, width, and offset. So this allows me essentially to set the width and height of the bounding box and offset it, move it to where it's got to be so it captures the entire image. Next, I created a type, so we can use this in the future for better logic. You know, is something a power-up? We want to get it. Is something an enemy? We want to avoid it or stomp it. Is something a block? We know we can walk on it. So this type tells the AI what this template, what is this object? What can I do with it? Then I have a color. This just is for visual representation. So in this case, blocks are using this magenta color. This is where we talk about the priority. So we prioritize things. Number 1 is going to be the highest priority. Number 5 is going to be the lowest. So enemies are going to be looked at as the highest priority. They're going to get updated as much as possible versus blocks, which can be pushed to a intermittent update interval. And then finally, I have a threshold and a max. So the threshold is the threshold that we would consider a match. That's kind of self-explanatory. So if it was a perfect match, it would be 1.0. But of course, with the screen moving and buffering and all that, so we can set a threshold that works. You can play with that. So this turtle, you know, I used 0.9 for the blocks. That worked fine. I used, if it's none, I think it defaults to 0.95 is what I think I put in the default argument. You know, Mario, I'm using 0.8 and 0.7. That works pretty good so far. So that seems to work good. This isn't super important. You can play with that. But what is important is this method, and this is what I'm going to implement in the next section. We're going to have 2 methods. One method is called max. Max means we know that there's only one of those objects on the screen. Give me the best one. That's quick and fast. So Mario, we know Mario can only exist in the game in one spot, so we can use the max quickly to find Mario's location. Other things like mushrooms, I don't think there's any situations where there's multiple mushrooms on the screen at one time. So I've set I'm going to try to set some of the things to max where it makes sense, but let's look at things that aren't going to be max, like enemies. So we already know it is possible to have multiple Goombas on the screen. So I've created a method that I'm calling all max. So I'm going to look for everything, or I probably should rename that to all. We want to find all objects that meet that threshold. And I haven't implemented this yet. That's what's going to be in the next part of this update, the next update that I do. So this is the first big update to my templates. I've structured this now so I can very easily add a template, and you can add your own templates. You drop your picture in, your template, and you follow this, and this allows the code to know where to get the file, where and how to use that. Is it an enemy? Is it Mario? How do you want me to display the bounding box? What is the size of the bounding box, etc. And what we can do is when we start our AI agent up, in my init here, I basically chunk them into different priorities. So I have priority 1 through 5. So essentially, this initialization is just going to go through that file, find all those templates, and it's going to create a list of templates and put them into different buckets, priority 1 through 5. So the priority 1 templates are going to go through a lot more cycles than a priority 5 item. So that's what this is doing here. So when we create our Super Mario instance, it loads all the templates in, bada bing, bada boom, you're all set. So that's what's happening there. And then let's look at the find templates method. So to keep it simple and sweet, this is where I was talking about that movement. So, basically we're going to use some booleans. If we know Mario's facing right because we've pressed the right button, or the game AI has, then we need to set Mario facing right we set this variable facing right as true. That helps the AI when it's looking to know how to fine tune to find Mario a little bit easier. We're going to use that. I was just playing with some different booleans. We're probably going to implement this later, but we're going to basically have some status for Mario. So it'll be like, is he facing left or right? Is he do we think he's jumping? Yes or no? Is he big or small right now? That kind of stuff. So for example, if we know Mario is big, let me jump down to the code here. So for example, if we know Mario is big, we don't have to look at the small templates, the Mario small. But we're going to want to occasionally check to see has his size changed. So we probably don't have to do that on every frame, but maybe like once every 10 frames or something, we check, did Mario happen to get a mushroom? Is he now bigger? Did he get hit? Is he smaller? And then we can direct our AI to start looking at the closer template. So that's a way where we can limit the number of processing we're doing, the amount of processing, which is very important for this. And we kind of guide the AI to monitor the correct template at the right time. Just like you do. If you get hit and you're small now, your brain knows, okay, I'm small Mario now. So your brain, subconsciously, you're looking for the small Mario. You're not looking for the big one anymore. So we want the AI to do the same thing. So how did I implement this prioritization? Well, what I did was I have a frame counter. So basically, as the thing is running, and it's really a misnomer. It's not the frame like a visual frame of the game. This is actually a cycle. Let's call it like a cycle through a calculation cycle. So probably a better name would have been cycle, one calculation cycle. But basically, I chunked the code, and we have this cycle counter going. And there's going to be certain things that are computational expensive that we might want to do on every frame. So we can do mod 1 equals 0. So that means anything divided by 1, any whole number divided by 1 is going to give you a 0 here. I left it like this so that I could update this. I'm going to play with this. Maybe we can go to a mod 2. So we only check this stuff every other cycle. There's going to be other stuff, though, like the blocks, for example. We probably don't need to check those on every cycle of our applications, saving computation time. Maybe we can get away with doing that just on every 5th cycle, or maybe even every 10th cycle. So that's what I'm going to start playing with. And the effect that'll have is, as our number of templates grows, let's say we've got 1,000 templates, maybe we're only checking for 10 of them at a time, 10 of them on every cycle. And then the next group we're checking maybe every other cycle. And you might say, well, how, eventually you're going to have to check for 1,000. That's going to get really slow. But again, that goes back to that logic. What do we know about the game? What can the AI learn about the game to eliminate the things that it has to check for? So for example, one thing that I was already thinking about is using like PyTesseract, which is an OCR, a text recognition tool. We can figure out what level we're on and just calculate that once every, a very long time. That can be a very long cycle. We don't have to check that constantly because you're not going to constantly change levels. Maybe we check that every 100 cycles or every 200 cycles, since it's a little bit of an expensive calculation. We do that text recognition. We know what level we're on. Now we can direct our AI to know what type of things to start looking for, what type of templates to look for. If we're not on a swimming level, think about yourself. If we're not on the swimming level with Mario, you're not going to be looking for fish, unless they got the jumping fish in this. I think they might. I don't get very far in Mario. But you get my point. If it's not a swimming level, you're not going to expect to see those squid guys moving around on the screen. If it's Mario, if it's level 1-1, you do expect to see the Goombas and the turtle guy. So that's another type of thing that we can do is using knowledge-based artificial intelligence, where we give the AI a certain amount of knowledge, just like a person would have. Here's some knowledge. Use that knowledge now to make good decisions. So that's also one of the things that we'll be looking at doing. So go ahead and download this code, pull it, try it out. Let me know what you think. I'd love to hear your feedback in the comments, ideas, suggestions, things I did good, things that I did bad. Let me know, guys. This can be a collaborative effort together. And also, if you're enjoying this, again, please consider liking and subscribing. My channel's pretty small, hoping to grow it. I enjoy doing this type of content, and I hope you enjoy it too. So I look forward to seeing you in the next update video. Hope this was enough information, not too little. Hope it wasn't too much. Let me know too. I want to make these updates interesting, informative, and useful. So I look forward to seeing you next time, guys. Have a great day. Bye.